So picture this. It's 2015. The world is celebrating this massive public health victory. We, as a global community, have officially hit a key Millennium Development Goal, MDG 7C.
Right, the one about drinking water.
Exactly. The goal was to have the proportion of people without sustainable access to safe drinking water.
A huge, huge undertaking.
It was this monumental achievement. Or at least that's what the data told us. But what if that data we celebrated was, fundamentally flawed?
And that is precisely the core question of the research we're diving into today.
Okay.
The official figures, the ones that showed we met that goal, they relied on a single, easy-to-measure metric.
Which was?
The type of water source.
So the Joint Monitoring Program, which was tracking all this, they just classified sources as either improved or unimproved. That was it. That was the global scorecard.
That was basically it. And what's so fascinating here is that the goal wasn't just about access to a source, it was access to safe drinking water.
Right. The key word is safe.
The study we looked at takes actual water quality data from 5 different countries and asks a really simple question.
Yeah.
How much did that simple plumbing metric, the source type, how much did it actually overestimate the number of people with truly safe water?
Okay, let's unpack this.
No.
Because if a source is classified as improved, doesn't that mean the water is safe? I mean, why would you even bother with that classification if it doesn't guarantee safety?
That's a really important question, and historically the assumption was, well, it was pragmatic.
How so?
Building a protected well or installing a pipe system, that's expensive infrastructure. So for policy, for measurement, it was just assumed that if you invested in the infrastructure, you solved the safety problem.
And the study shows.
The study shows that the simple answer is a definite no. We were, in a sense, trusting the pipes instead of actually testing the water.
So our mission today is to look past that global celebration, get into the cold, hard quality data, and really try to quantify this invisible gap between having an improved source and actually having clean water.
To really get why there was an overestimation, we have to look at the metric itself. I mean, this JMP classification system, it created the entire global baseline for that MDG goal.
Okay, so you had the easy categories, the unimproved sources.
Right.
That's your surface water, unprotected wells, tanker trucks, water vendors, stuff like that.
Exactly. If you use those, you were counted as having unsafe access. Simple.
And then you have the other side, the improved sources. These are the global standard bearers of safety, right?
Supposedly. This included things like piped water directly into a house or a yard, public taps, boreholes, protected wells, and rainwater collection systems.
And the core assumption, the policy assumption, was simple.
Yeah.
If you use an improved source, your water is safe.
And the study just argues that this single assumption leads to a substantial overestimation of access to safe drinking water.
But why rely on a proxy like that in the first place? Why not just test everyone's water all the time?
Well, in a word, cost. And consistency. I mean, think about it. Testing for contamination constantly across thousands of rural and urban water points in a developing nation, it's incredibly complex. It's expensive.
So measuring the type of infrastructure was just seen as a necessary shortcut for speed and consistency.
It was. However, the researchers here, they didn't rely on those proxies. They did a quality check. They used data from the Rapid Assessment of Drinking Water Quality Project, the RADWQ.
So this is like the definitive quality control audit on that global promise.
You could think of it that way, yeah.
And they followed the World Health Organization guidelines right to the letter, meaning they weren't just checking if the water was clear. They were checking for the invisible killers.
Exactly. They tested for the critical contaminants. First, thermotolerant coliform bacteria.
Which is the big one for
dangerous fecal contamination. Basically, if you find coliforms, you know something potentially deadly is in that water.
Okay.
And second, they checked for persistent chemical threats, arsenic, fluoride, and nitrates, which are often tied to specific geology or, agricultural runoff.
So they took the population that was counted as having improved access in 5 key countries.
Ethiopia, Jordan, Nicaragua, Nigeria, and Tajikistan.
Right. And they essentially challenged the big MDG claim by measuring the actual safety of the water those people were drinking. It's like an audit of the audit.
And if we connect this to the bigger picture, the flaw is assuming that just providing the infrastructure is the same as guaranteeing the public health outcome.
It's not just about the pipe.
Not at all.
Yeah.
The study focuses on these countries to show that the reality on the ground, the maintenance of that pipe, how the water is handled, that's what truly dictates safety, not just the initial classification of the source.
Okay, let's get to the numbers, because this is where the picture really shifts from a global victory to, I don't know, a statistical earthquake.
It's a big shift.
When the researchers adjusted the JMP figures, so they only counted populations whose water met those strict quality standards, the access figures just plummeted.
They did. And these drops were not minor rounding errors. They represent millions of people who, on paper, were hitting the MDG target, but were actually still drinking unsafe water.
Wow.
The overall compliance figures for the 5 countries, this is from 2008 data, showed really substantial reductions.
So tell us about the biggest adjustments. I want to start with the most dramatic one, which I believe was in Nicaragua.
Nicaragua, yes. It experienced the largest single country adjustment. Their estimated proportion of the population accessing truly safe drinking water was reduced by a whopping 15%.
15%. That's devastating to a progress report.
It is.
It means that for every 100 people the world celebrated reaching with safe water in Nicaragua, 15 of them were still vulnerable to waterborne disease.
Mm-hmm.
That's just a massive misallocation of perceived success.
It absolutely is. And it wasn't just there. Ethiopia saw an 11% reduction when water quality was applied to their 2008 data.
11%. Still huge.
And in the other countries, while the numbers were smaller, the effects were still critical.
What were the rates for the others?
Nigeria and Tajikistan both saw their estimates reduced by about 7%.
Okay.
Jordan, on the other hand, had a much smaller adjustment. It dropped by only 1%.
And that 1% figure in Jordan is an important contrast, right?
It is.
It tells us that some improved sources really do deliver safely. But the 11 and 15% drops, they highlight the danger of treating all improved sources as if they're equal.
Precisely. And if you look at the total effect of this, the revised estimates for safe water access were substantially lower than the original baseline figures from way back in 1990.
Wait, hang on. I want to emphasize that point, because that just compounds the failure.
It does.
It's not just that we overestimated the progress made during the MDG period, but the study is suggesting we probably had a much lower starting point in 1990 than we ever believed.
That's right. If you realize the starting line was actually much further back, it means the perceived progress toward the goal was even more artificially inflated than we thought.
The gap between the promise and the reality just grew exponentially.
So why the huge drops?
Yeah, why the huge drops in places like Nicaragua and Nigeria, but such a minimal one in Jordan? If the source type was the same on paper, the failure must be somewhere in the delivery.
It is. The study's analysis makes it clear that we have to distinguish between microbial and chemical contamination.
And the source of that contamination.
In the source. Let's start with the one causing the biggest headache, the microbial issues.
Was that the main reason Nicaragua and Nigeria dropped so much?
Yes. Microbial contamination, specifically the presence of thermotolerant coliform bacteria, was the primary reason for that big reduction in estimated safe access in both Nicaragua and Nigeria.
Okay.
And here is the absolutely critical detail from the research. In many cases, the source itself, the borehole or the protected well, was actually clean when they sampled it.
So the contamination is happening after it leaves the source.
Often, yes.
Yeah.
After the water leaves that protected source.
It's the classic last mile problem, but for water. You fix the big complex infrastructure, but you didn't fix the final human interface.
Exactly. This recontamination happens because of things like poor handling and storage practices in the household.
Like an open container or using a dirty scoop to get the water.
Things just like that. Or it happens in the distribution network itself. Maybe there are cracked pipes allowing groundwater contamination to seep in close to the point of use.
So the assumption that no contamination occurred between the source and the point of use was just demonstrably false.
It was a major flaw in the model.
Wow. So you can install the most technologically advanced pump in the world, but if the bucket someone uses to carry the water home is dirty, the MDG target is compromised.
That's it.
That makes safe water access as much a behavioral and hygiene issue as it is an engineering one.
It absolutely does. Now, let's look at the other major threat, which was chemical contamination. This was less widespread, but it was regionally very significant.
And where did that play the biggest role?
In Jordan. That's where we saw the microbial issues were low, but the chemical contaminations,
That's right.
specifically high levels of naturally occurring fluoride, arsenic, and nitrates, that was the main factor pulling down their safe access figures.
That makes sense. Chemical issues are usually geological or industrial. They require much more advanced treatment at the source, which is often more complex and expensive than dealing with microbial issues.
It is, but the study does offer a glimmer of hope. It confirms that when improved sources are well maintained, they are extremely reliable.
Like in Jordan.
Exactly. The piped supply in Jordan, for example, was reported to be virtually entirely free of both microbial and chemical contamination. We're talking less than 1% non-compliant.
So the system can work flawlessly.
It can, but we can't just assume that level of compliance globally.
The lesson here seems to be that the problem isn't the improved source type itself. It's the poor maintenance and the lack of monitoring that made the definition such a poor proxy for actual safety, especially for those microbial threats.
And if you're listening and wondering why some statistical adjustments on 2008 data matters to you today, it comes down to a fundamental truth.
Which is?
Accurate data drives effective policy. It drives resource allocation.
Right. If governments and NGOs thought they'd already hit the goal, but they actually missed it by 15% in a place like Nicaragua,
then resources weren't allocated to fix those gaps. People were left behind.
it creates a false sense of security, which you could argue is even worse than knowing you have a problem.
Absolutely. The conclusion of the study is forceful. It says the criteria used by the MDG indicator must fundamentally evolve to account for water quality.
So for future monitoring, like for the current Sustainable Development Goals, it's not enough to count pipes.
Not at all. Monitoring safe drinking water needs to record both access to improved sources and compelling evidence, through testing, that the water is actually safe to drink.
This means we can't rely on simple infrastructure completion reports anymore. The global scoreboard has to show quality metrics, not just quantity.
And that brings us back to that baseline problem. Since the study found the actual baseline for safe water back in 1990 was probably much lower than we reported, the progress we celebrated was, well, it was artificially inflated.
The world was even further from the finish line than we realized.
And if we repeat this same error with the current Sustainable Development Goals, we risk making the exact same policy mistake years from now.
That's a pretty profound finding. It means global targets were set on fundamentally shaky ground.
And the difficulty the researchers had just acquiring this consistent, high-quality water data, it highlights the massive ongoing data gaps.
So we need a huge investment in monitoring.
We need substantial investment in national monitoring systems that are designed for continuous quality checks, not just, occasional source counting.
It really sounds like the key realization here is that the JMP data, while it was useful for measuring infrastructure investment,
Sure.
it was simply an inadequate proxy for public health impact. It measured capital expenditure, but it didn't measure disease prevention.
And it shows that the pursuit of knowledge requires constant refinement of our metrics. The study strongly suggests that future monitoring programs have to prioritize continuous, national-level assessment of actual water quality. Otherwise, we're just celebrating infrastructure victories that might not translate into public health benefits at all.
So the key insight from this deep dive is powerful and really pretty simple. Classifying a water source as improved does not make it safe.
Not inherently, no.
The study showed that globally, just ignoring water quality, especially that invisible threat of microbial contamination, can lead to overestimating safe access by as much as 15% in some countries.
And it reveals that this invisible gap, the gap between what the infrastructure promises and what the water actually delivers, it's often due to system failures or hygiene practices in that last mile of delivery.
So what does this all mean for the future of global development targets?
Sure.
The challenge of securing safe drinking water isn't just about pipes and pumps anymore. It's about ensuring these invisible threats, the microbes, the chemicals, aren't undermining our biggest public health gains in that crucial final step right before someone takes a drink.
Exactly.
And here's a final thought for you to take away. The study clearly pinned microbial contamination as the primary culprit overall. And that contamination, it said, often happens after the water leaves the protected source.
Re-contamination issue.
So think about the implications of that. If the problem is really about poor handling and storage at home, how does household water treatment and safe storage factors that are not currently monitored by source type at all, how do they become the next major pillar of global water safety efforts? It sort of shifts the focus from engineering the source to auditing behavior and education in every single household across the world.